And remember, when we're talking about basophils, we're talking about these kind of darker blue, purple staining granules and nuclei. With neutrophils, we said they're kind of more of a neutral pink color. With eosinophils, these are going to be more of the acidophiles, right? They're going to be more dark pink, dark red staining overall. And again, throughout this chapter, right, the big thing is really these granules. What are in the granules? Well, the most important thing to know about eosinophils is that the granules contain major basic protein, which is absolutely critical in the destruction of helminths specifically, and different types of parasites. They're going to be very effective against helminths. And so that's part of the reason why if we have a helminthic infection, we're going to have a lot of eosinophils. We're going to have upregulation of eosinophils, upregulation of IgE, and a lot of this is going to be driven through interleukin 5. Okay, so that's the big cytokine to remember when you're thinking about eosinophils. Interleukin 5 is going to upregulate, specific adhesion molecules, right? So that eosinophils can bind to the site of an infection, okay? So they can get to where they need to go. But then it's also going to stimulate just the overall proliferation and differentiation of eosinophils. So again, interleukin 5, particularly high yield when you're talking about eosinophils. Now, eosinophils will also have additional chemicals. I put another one on here, histaminase, but again, not quite as high yield as the major basic protein. Generally, in terms of the lobes, we talked about neutrophils having 3 to 5 lobes. Eosinophils tend to have 2, and you can kind of see that depicted here in this image. And here you have 2, it almost looks like 3, but in general, you'll usually see 1 to 2 lobes. And more importantly, when you're in a situation where you feel like you have to make a tough decision as to, what type of cell they're asking you about, you just look at the color here, right? These are going to be more acidophilic, much darker red staining than what we saw with the neutrophils. Now again, because eosinophils have major basic protein, right, we would expect that they would have some component of degranulation, right? So they can release this major basic protein. And like we said, they're very much associated with the parasitic immune response because they have a very effective mediator to target that type of infection. When we're talking about chemotaxis with neutrophils, we said neutrophils get to the site of acute inflammation through things like LTB4, interleukin 8, C5a. When we're talking about eosinophils, we just said that there's an upregulation of adhesion molecules that help get eosinophils where they need to go. Similar to what we saw with neutrophil adhesion molecules. Okay, and again, what's it all driven by? It's driven by interleukin 5. Now, there's also some components of histamine involved here, right? When you have basophils degranulating, right, that degranulation of histamine can cause eosinophils to get to the site of reaction. And that's why when we have allergic responses or allergic reactions, all of the degranulation from the type 1 hypersensitivity reaction from things like basophils, from things like mast cells, that can all lead to the stimulation of eosinophils. Right? That can stimulate eosinophils. And so that's why we can see a very high level of eosinophils in the setting of atopic disease or in the setting of an allergic reaction. Okay, so eosinophilia in general, right, relating this all together, can be in the setting of a parasitic infection, like we just said, where we would want to release major basic protein, largely driven by interleukin 5, or with asthma and allergies, right? When we have a lot of histamine being released, for example, that can also do it. One thing that often gets confused here is because interleukin 5 stimulates eosinophils, for some reason, it tends to be thought that interleukin 5 actually causes class switching to IgE. Remember, it was interleukin 4 that largely drives class switching to IgE. Okay, so interleukin 4 will drive this process. And this is exactly what we saw in the type 1 hypersensitivity reactions. Interleukin 4 released from the T cell, right, to the B cell factories causes class switching through interleukin 4 release. Now, interleukin 5, on the other hand, will cause class switching to IgA. This is a part that often gets confused, and it's kind of a straightforward thing that you don't want to miss questions on. Eosinophils also have the ability to undergo phagocytosis, specifically through antigen-antibody complexes, but again, this is probably the least high yield on the list here. We went through the pathology already. Just one of the things here to be familiar with are these interleukin 5 antagonists, the mepolizumab. If you had tons of inflammation from, eosinophilia or from, one of these allergic type of reactions, and you wanted to curb, your eosinophil activation, you block the binding of interleukin 5 to cause stimulation of eosinophils. And that's essentially what this monoclonal does. It's going to reduce the number of developing eosinophils and inhibit the eosinophil recruitment, right? The adhesion and the proliferation, all by acting as an antagonist at the interleukin 5 receptor.